The law of cosines is a generalization of the Pythagorean theorem. We'll use this theorem to solve triangles that don't contain a right angle. And the theorem states the following. In any triangle ABC, such that we see on the screen, we have the following relations. Now we'll go ahead and derive one of these equations, and the other two equations will follow by symmetry. To begin this proof, we want to place our triangle ABC so that the point that's next to the angle A is at the origin of the xy plane. Then this point here is given by the coordinates c, 0. This point here is given by 0, 0. And we're not sure what this point is yet, so we'll label this point as x, y. To find the point xy, we need to go ahead and construct a right triangle. Then we notice in this right triangle, the base is given by x, and the height of this right triangle is given by y. Now we have a relationship that we can use. The cosine of A is going to be equal to x divided by b, and the sine of A is going to be equal to y divided by b. In other words, the x component of our point is going to be given by x is equal to b times cosine of A, and y is going to be equal to b times sine of A. And the last thing in this proof is to notice the distance between this point here and this point here is given by A. And now if we square the sides, we're going to get our solution after we simplify the left-hand side. So let's go ahead and simplify the left-hand side on the next page. Simplifying the left-hand side now, this is going to be equal to x minus 0 x minus c raised to the second plus y minus 0 raised to the second. Recall we have the following representation of our x's and y's, so let's go ahead and replace this, and our equation now becomes the following. Again, we need to continue simplifying the left-hand side, so foiling out our two terms here, we'll get the following. In this new expression, we can simplify it further by combining the term b squared cosine squared a with b squared sine squared a. These two terms, when we add them together, have the following property that this is just going to be equal to b squared times 1. Then, using this identity, we'll get b squared plus c squared minus 2bc cosine of a is equal to a squared. And this proves the law of cosines. Again, law of sine and cosines are useful to solve triangles that do not contain right angles. And the law of sines states that the length of the side of a triangle is in proportion to the sine of the corresponding angle. More specifically, law of sines was used to solve two different cases. Either we're given one side and two angles, or we're given two sides and the angle opposite to one of those sides. On the other hand, law of sines is a generalized Pythagorean theorem, which again is given by the following equations, and the law of sines will be helpful for solving the remaining two cases. Either we know two sides and an angle between them, or we know all three sides. Let's also go ahead and note the following. If one of the angles of our triangle is in fact 90 degrees, let's say as in this equation here, then when we plug in 90 degrees to our cosine, the negative 2ab cosine of 90 degrees disappears because cosine evaluated at 90 degrees is 0, and we get the Pythagorean theorem. And this is why we call the law of cosines a generalization of the Pythagorean theorem, because we can derive the Pythagorean theorem from it.